Welcome to the Innovators Playbook podcast. I am your host, Seth Narayanan, founder and CEO of Telient Systems. Each week, I'll be sitting down with entrepreneurs, product leaders, and technologists who are solving real world problems with bold ideas and smart execution. We will dig into what is working, what's not, and the lessons they have learned turning vision into reality. If you're leading digital transformation, scaling a startup, or just curious how innovation really happens behind the scenes, this is your playbook. Let's get started. Welcome, everybody, to the Innovators Playbook podcast. I'm your host, Seth Narayanan, founder and CEO of Telient Systems. I'm thrilled to welcome Christopher Mallinson to the podcast today. Chris is the Director of Software Engineering at Nanotronics, where he leads teams building next-generation software for advanced manufacturing systems. With deep expertise in C++, robotics, and embedded systems, Chris works at the intersection of hardware and software to support some of the most innovative inspection tools in the semiconductor industry. His background includes building Arduino-based firmware, contributing to real-time systems, and exploring how automation and software engineering can transform precision manufacturing. Chris also brings personal curiosity into machine learning and Python, continuously expanding the boundaries of what software can do in high-tech environments. Chris, welcome to the Innovators Playbook podcast.
Thank you, Seth. Thank you for having me.
Absolutely. Let's get started. What first got you into robotics and embedded systems? A particular spark, moment, or project that kind of pulled you into this?
Yeah, I'd actually say that I probably had a few moments. As early as high school, I was in a class. It was my first ever experience with programming. And I had a really good teacher who didn't really let it be just the classic open book, pencil, notepad, and that type of lecture. She was very good about having games. It was interactive. And I really fell in love with coding at that point. From there, I went to college. I wanted a little bit more hands-on with hardware. And the first time I ever got to use a robot and kind of build a robot, that's really where the spark really ignited for me. It almost felt like I was in like a bit of sci-fi, watching these robots come to life. And they were doing small things. It was pathfinding in a maze or communicating with a light tower, but it definitely made it a lot of fun, really ignited that spark. And that's what drove me to my first job, where I decided to write software for hardware. I was at a company. They worked on radars for helicopter systems. And I remember looking out of the helicopter. It's a cloudy day, you can't really see much. And at this point in my life, I was just used to seeing radars where it's like what you see in a movie. There's that sweeping green line. You get a little blip on the screen when it detects something. And I thought it'd be a little bit boring, a little bit basic. But what I was actually seeing on the screen is almost a full dotted picture, looking at a boat miles away, just waiting in the water, something I couldn't see with my eye out of the window. But here I was watching it on my screen. I thought that was so cool. I stared at it the rest of the day, and I don't think I got any actual work done.
Wow, cool. Robotics involves both hardware and software. So do you have a preference towards one or the other, or do you kind of enjoy the interaction between both?
Probably depends on the day. Software, I've always had my initial love for, and I think I'll stay with software probably for the remainder of my career. Hardware is a lot of fun when you have the final product, and some of the integration is a lot of fun, but that's usually what gets me to pull my hair out the most also. You can't understand something, it's a lot harder to debug the hardware side of things. I'd say I lean a little bit more software than I do hardware, probably for that reason.
Yeah, but it is very cool to see using software to control physical things. So I've had a little bit of experience with that, but what you're doing is really cool. So you worked across low-level firmware, automation, and AI-enabled detection, etc. How has your approach to building and leading software teams evolved along the way?
Sure. When I first started, I think a lot of what I had in mind was a little bit more monolithic, I'll call it. Everything was one conglomerate, and that's just how we ship tools. Over time, I started to see a lot of value in separating everything out and just gluing them together with stronger interfaces. It's a lot easier to build flexibility. It's a lot easier to build something right when you take the time up front, as opposed to trying to rush to get something out the door, and now you have to integrate something new with older components, and it gets tough. I equate it in my head to almost like a Jenga tower, right? If you have one issue in a larger set of functionality, it can be hard to find that issue. It's going to stack up the problem. It'll be a lot harder to find what the cause of it is, as opposed to if you're building out a bunch of smaller towers, it's a lot more isolated, becomes a lot more easier to work with, and it ends up just making more sense in the final product. It's a lot easier for your customers to understand. An added benefit to that as well, when you have a team In my case, with what I do, we have an AI expert, a robotics expert, we have firmware developers, software developers, but it's very rare that all four of those qualities are in the same person. If you separate out your components and you do a good job of defining responsibilities for each one of those components, it makes it a lot easier to design out work. You don't want your robotics engineer having to worry about having downstream effects on the AI detection. So just splitting that out really helps a lot with the overall build.
Yeah, that is really interesting. I think I'm always interested in how teams come together and what individual roles need what kind of skills. So, how do you spot people? And when you find people that are maybe not ideally suited for one role or the other, do you guys figure out a way to maybe swap roles? And how do you keep them all trained and rowing in the same direction?
I think that's a lot of trial and error. I can't have my whole team just split up and everybody's completely isolated. If I lose one robotics engineer, then I don't have another. That would be a very poorly built team if I did it that way. Thankfully, not every task we get is this giant groundbreaking feature that I need an expert for. A lot of times it's smaller things. It's a little bug or a tiny feature, something that I can give to somebody who might not be as well versed, and I can build them and guide them. Half the time they turn out loving it and they ask for more of it. The other half the time they say, please don't ever give me a test like that again. So it's all about seeing where people like to work, what they're good at, and it just becomes a natural fit once you give everybody the opportunity to work in different areas.
So, in your daily, day-to-day routine, what part of it do you get to work on your own projects versus team management and team building?
I would say that is very often not defined by me, but rather for me.
Okay.
We sell tools somewhat globally. So a lot of times I come to the office and I have an idea of what I'm going to work on that day. And come to find out that overseas there was an issue overnight. And now that's become my entire day. So when I don't have an emergency first thing in the morning, a big step for me is how can I be ahead of the curve? How can I predict what the next issue is going to be? And how can I build my team for that? It's almost like I'm looking at a stat sheet for my team, almost like I'm building a character in a video game. What's our current weakest link? How do we get that better? If there's no real weak links at the time, how do I automate something new so that way I can buy myself some time back later? So a lot of it is just how do I earn time from the future instead of wasting time today?
Interesting. You build at Nanotronics tools that merge hardware and software using robotics. So, is one of the challenges that you face getting the integration right? Or should I ask, what challenges do you have in the integration aspect of it? Do you run into situations where the hardware doesn't match the software? Obviously, it's probably easy to change the software, but maybe it doesn't achieve the purpose if the hardware is not doing exactly what it's supposed to do. So, talk a little bit about that for those that are outside of that very interesting area.
It's very funny that you said what you said, that it's easier to change in software. I do agree that is true, but that often gets us into trouble.
Yeah.
There's a common saying in engineering that there's a 10x rule of quality. And that rule basically states that the longer an issue goes, farther along it gets in the process, it gets 10 times harder to fix and 10 times worse each stage that you let it get to. So what used to be common in my company is we followed a waterfall method, which just meant that in our case, the mechanical team got a task, they finished the task to completion, they'd move it to the electrical team and the firmware team, they would do what they need with it, then they'd pass it to us in software. If there was an issue that went unnoticed at that point, software would go back to them and say, hey, is there something we could do about this? I have a bug here, or this wasn't designed to the original spec. And unfortunately, the issue usually was it'll take us too long to go back all the way, reproduce something, generate a new part, order new boards, and I would have to work around it in software. So one thing that really helped us with that is how do we sit everybody down? How do we get input from all the teams early on? So that way, when everybody goes out to design what they need to design, we're all working on it simultaneously. We can give each other input all at the same time. And that really ends up building a rubric for your quality teams, which is another added benefit of kind of doing everything up front like this. So to answer your question, yes, I do think that hardware design is one of the tough things just because how long it can take to go back and iterate on the process. Whereas in software, it's usually much faster to iterate on.
Yeah. I don't want to put you on the spot, but is the software more buggy generally than the hardware? Are there less issues on the hardware side because it's more physical and more defined before hardware gets made, or is that not true?
It definitely was the case a lot more in the past before when we had that waterfall methodology, because then we had to work around problems that we weren't expecting to have. So we're on much shorter timelines trying to get these out. Nowadays, I'd say it's a lot more even. There's still much more work in software just because we're doing smaller iterations on our firmware, whereas most of our tools controlled in software. So yes, there are more bugs there, but I would definitely say we've done a good job of balancing where the issues lie.
So in your field of robotics, where do you see the next big breakthrough coming? Do you see it in automated testing? Do you see, of course, we'll talk about AI in a bit, but other than AI, what areas do you see as breakthroughs that are in the offing?
So without talking about AI and targeting this a little bit more to my industry. So in the semiconductor industry, the tool that we build, because we're inspection side, we have our robot going through a load process. We're aligning a sample before it gets to our stage. Once it's on our stage, we're scanning it, we're capturing images at a microscopic level, and then we're analyzing it. One thing that I think is very big for us is how can we detect what we call sample killers before we even get to the scan and analysis phase. So a sample killer to us, if I'm looking through a microscope, yes, there's going to be tiny defects. I shouldn't be able to see those by eye. If I'm looking at the sample and I can see a line drawn straight across the whole sample, it's likely to be a sample killer. That's something that no customer is going to want going through the rest of their process line. It's a scrap sample. They're going to want to get rid of it. So one of the things that we're working with on our tools is how do we detect those sample killers before we even get to the stage? Because once we get to the stage, it's maybe a 2 to 3 minute process to scan and analyze everything. And if we could skip that altogether, it'll save us a lot of time in the morning. 2 to 3 minutes might not sound like a lot, but if you put in consideration that some of these customers are running 24/7, now 2 minutes for a handful of these samples, it starts to stack up to hours and so on. So every second will count if we can find ways to cut it out.
That is really interesting. Are there new technologies or hardware components you've been exploring with your team that you're excited about recently?
I would say there's a few. On the robotics side of things, this is something that exists in the field, but not necessarily on our tool yet. There's a concept of a dual end effector on your robot. So again, going through that process, we pick up a sample, we align it, and bring it to the stage. When we get our next sample, because the one on the stage is completed, it'll take a few seconds to pick it up, put it back, get the next one, go through that process and put it back on the stage. Whereas if you have multiple end effectors, you pick one up, immediately drop it off, and you now save yourself a few seconds, which again, when we're talking about the stack of those customers running 24/7, it becomes a lot more than we would think. So that's something that's always been very exciting to me. How can we work with these end effectors? One other concept we have in R&D is what if we had a station that had end effectors we could swap as opposed to just having multiple end effectors? Some of our customers might say, I want to only touch the edge of the samples instead of using a vacuum grip on these samples. They might have devices printed on the bottom of the sample, so they can't use the vacuum that's going to touch in the middle. How can we make these decisions at runtime? And how can we continue to iterate on our process and cover as many customer use cases as possible? And that's where a lot of our R&D is right now.
Interesting. We skipped AI earlier, but obviously that is front and center of what's been happening in the world of technology over the last, 3 years. So what's going on specifically in your industry and specifically in your company and in your products that you're most excited about and maybe also concerned about?
Sure. Going back to the defect killer I was talking about earlier, or the sample killer I was talking about, I think that might be a good place that we can inject AI into our tool. When we're talking about AI, we're talking about how do you communicate with something that is going to give you a different response or might give you a different response every time you talk to it? How do you test something when you have no idea what the output's going to be? So there's a lot of ways in which AI can be scary to add into our tool. One thing, the context here is these samples that we're moving can cost anywhere from $20,000 to $30,000 for a single one of them. If we break any of those, our customers are not going to be happy. It's expensive. They have to bring the tool down, which is going to just have more costs before they're able to get it back up.
Right.
So how do we add AI when we don't know what the outcome is going to be? And how do we integrate it when we don't have the capabilities to test it? So going back again to those sample killers, maybe that's something we could use it for, because worst case, it's a yes, no to scanning something. The worst case, the sample is still safe. It goes back into our carrier and we just don't scan it. What gets a little bit more exciting, but also a little bit more scary is what if we used AI for optimizing our robotic path, knowing what task to do next to save the most time overall? That's where things get a little bit less trustworthy because now you're talking about actively moving samples with the robot and that can result in a crash. That can be a lot more dangerous to our tool.
Yeah. I know in terms of software, you do a lot of the coding in C++ still. And are there opportunities for using AI for developing some of this code and maybe even testing it using the latest AI tools?
I think there's definitely an argument for it. Personally, I use AI a lot in my side projects, right? I'm at home, I want to learn something new. AI is very good for me in that way. It's something that I can speak to that has a plethora of knowledge of the internet, much more than I'm going to have. My research is typically a Google search. I look at the first few links and I kind of move on from there. The problem I've always found with AI, again, is how do you get the right answers out of it? How do you validate what you're getting out of it? And to that point, I think it can work pretty well to make smaller fine-tuned features, especially if it's something you could end up testing. But I don't think it's quite at the scale yet where it can replace a developer. And honestly, I don't know if it will get to that scale.
Yeah. So you think that's true even with the robotic inspection space? Can AI be used to make it faster, cheaper, maybe better?
My answer is going to be yes, if you use it in the right spots. So like, for example, even before the AI boom, we used it a lot on our defect detection. So this is after we've already scanned a sample, we have the images, and we just want to see where the defects are. Using AI for something like that is, in my opinion, pretty not low effort, but I guess low cost if it were to glitch and something were to go wrong. This is just a difference of not counting the right amount of defects. I think it's still a little scary to put it in anything that's robotic, anything that's handling. Again, just because there's so many more outcomes that are possible, and how do you test for all of those cases?
Yeah. Talking about tools that you're working on, what's the bottleneck that slows down the iterations and the reps the most? Is it hardware constraints or code base complexities or something else?
I would still argue that's hardware constraints. The common saying that we have around the office, and I think it's common in engineering, is software eventually works and hardware eventually fails. If I have to upgrade a system and I'm talking purely software, purely databases, that's something that I can easily test in-house. I'll run through it as many times as I can before it ever reaches a customer. And that's great. I can be confident in that. As far as the hardware goes, especially in our tool where we're stacking up multiple robots, multiple cameras, multiple stages, robotic control, and so on, you end up with maybe thousands of permutations of your tool, and there's no way that you're going to test every single one of them. If you build them out with isolated components, it might not affect your camera or whatever the larger picture in your project is. But the important thing is there's no way I can test every single one of those permutations. And even worse, if I'm talking software versus hardware, a customer comes to me with an issue. If it's software related, I debug it, I fix it, I ship them an updated build, and that should be the end of it. With hardware, we have to prototype. We have to wait for the prototype to finish. When it's finished, we have to order an official board to get to the customer. And one of the issues that we get a lot with our hardware is when you try to replace something in the tool, you're likely invalidating your calibrations. So if I'm switching out a light, for example, I now have to retune the light to how it was before. Maybe I don't have good data on how it was before. And now the customer is getting all different results out of their analysis. So I would definitely say hardware is still more fun, but harder to work with for that reason.
Are there still areas in your space where automation can be improved? Are there still a lot of manual processes in your company or in your industry in general that can be automated further?
That's funny. I actually think that in the semiconductor space, automation is one of the few things where they really have thought of a lot. I might even argue that they're over automated. I remember I got this one feature request from a customer, and they had asked for a notification every time a sample is placed at their tool. Now, every customer that I dealt with personally, I knew that they had operators inside the factory. They're the ones that are transporting from one station to the next. So in my head, I'm saying, okay, I understand what you're asking for, but I don't understand why. Why is it important? Why can't you just have your operator place it and start the scan? So I started going to these customer sites. I started looking through their factories, and I came across what's called overhead hoist transit. It's more commonly called OHT. So these factories that have OHT have these rails running across their ceiling, and those rails are basically a track system to move their samples from station to station. So now I'm starting to understand, okay, they've automated even moving between stations, let alone automating on one specific tool that they have.
Yeah.
So they're definitely pretty deeply automated in the semiconductor space.
Yeah, it's very interesting. Just from a layman's point of view, our garbage pickup Used to be, in fact, my kids wanted to be a garbage truck driver who would drive the truck, get out, come around and lift that heavy thing and dump in. And now they've got these nice robotic arms that come out and kind of make all that automated. And I was thinking there's a lot of work that he goes through, like positioning the truck the right way and so that it grabs it. And then he's going to have to go back and forth, and especially when you're in a cul-de-sac. I'm sure that truck can be automated, right? But I think those days are coming when all of that is probably going to be automated, which is both good, I guess, and scary. Talking about robotics and hardware in general, as the United States has been lagging a little bit compared to maybe Asian countries. So, what is your outlook for the US in the hardware and robotics space? Do you feel bullish? Do you think that there is potential growth and opportunities, and there are going to be US based companies that are going to continue to invest dollars and people in that space, or what do you feel overall about?
I would certainly like to say that I'm confident. It's my space, so if it's not going well, then it's a little doomy for me.
Yeah.
But yeah, I think there's a lot of opportunity. And I think one of the issues when you're looking at the global scale is just that it's so much cheaper to do automation or to build something in other countries. Labor's cheaper. Even though it's more expensive, I think that it is important to have it in the US. A lot of it is also just what's going on in other countries that maybe we can get a better piece of. I know for our industry, one thing that we're currently looking at and a new product line we just introduced is in our inspection tool, we're now using lasers instead of just LED lights. And that's because in a lot of Asia Pacific markets, they're looking at the next thing beyond semiconductors. What defects can they see with a different light source? So I think a lot of it too is just finding where the automation is going and trying to get a piece of it that way.
Interesting. We are nearly at the end of our time here. So, one question that I ask all innovators is what advice do you have for people that are coming up through high school and college and are looking for a career in robotics or in automation and maybe even in the semiconductor testing industry? So, what is your advice generally for students and young aspirants?
Honestly, one of my big pieces of advice, I would say, if you can work it into your future, try to work at a startup. I think a lot of people are afraid of startups because they say it's a little bit more risky. Who knows what's going to happen, how long the company's going to be around. But I can tell you from working at a startup myself, I have experience that I would never have if I was at a bigger company. And there's certainly benefits to bigger companies as well, but you will grow fast and you'll grow early. You'll do things that maybe you didn't think you'd ever want to do. And it turns out you're going to love it. I don't know that I would have had much firmer experience if I wasn't at the smaller company. I've even got to dip into the mechanical side of things a bit. And you really get a much better idea of the big picture. And I think that's something that you can take throughout your whole career.
Yeah, great piece of advice. Thank you, Chris, so much for your time today. You've been very educational, and I'm sure the viewers will find it interesting and learn about your industry and your company. So thanks a lot for your time today, and look forward to talking to you soon.
Thank you, Seth. It's been great.